are very lucky to have with us Dr. Leah Buechley. And as I was telling you guys before, she's in our computer science department, and she does a lot of really cool things with computing and the intersection between that and art, and also bringing technology to groups of people that might normally be really shy about it, like me. So I'm very indebted to her. And I told her that yesterday we started our sewing projects with the Lily Pad Proto Shop, but they've also been working with Arduinos in their Arduino class. So without further ado, here is Leah.
Hi, sorry, I got distracted. Yeah, it's really a pleasure to be here with all of you today. I thought I would talk a little bit about just like what I've done in my career, and then you could ask me any questions and we could just chat a bit. Try not to talk too much. Let me go ahead and share my screen so you can see. So you can see a visual while I'm talking. So I'm a professor at UNM, and I teach at UNM, I teach classes, and then I also run a research group at UNM called Hand and Machine, and it's kind of about exploring how people and technology work together and interact. And more specifically, like Steffi said, I'm interested in kind of combining art and technology and education and craft in different ways. So just to start, I wanted to say, as some of you already know, I grew up here in New Mexico. I really love the state. It's so beautiful and cool. I think we're all so lucky to live here. This is just a picture of close to where I grew up. I grew up near a little town called Penasco, if any of you guys know where that is. Beautiful, kind of remote. But anyway, I love New Mexico. I think it's awesome, and I'm really glad to be back here and working at UNM and stuff now. So yay, New Mexico.
One student from Penasco.
Yeah, I think we might know each other. So, or I might know his mom. So that's awesome. Yay. So I'll talk to you just about a few different projects that I've worked on over the years, and yeah, and then we can have a little chat. So one of the first projects that I started working on actually when I was in graduate school was figuring out ways to combine electronics with fabric and textiles. I've always been interested in fashion and design, and so that seemed, but I was getting my degree in computer science, and it seemed really interesting to try to like combine those things. And so I started playing around with just different ways that you could kind of put electronic pieces like into fabric in different ways. And it turns out there are these really cool materials, in particular like conductive threads and conductive fabrics, which I guess you guys have now played with some, that made it like possible to do this and made it possible to make electronic things that were soft and stretchy and colorful. And that just seemed really fun and cool. So I started to experiment with that. This is just a picture of a really simple circuit, like maybe similar to ones that you've made.
Your slides aren't advancing.
Oh, I'm being slow. So do you not see anything?
We just see your first slide, the title slide.
Oh, I wonder what oh, I see, sorry. I wonder what happened. Okay, my mouth, oh. Let's see. It seems like.
There you go.
I guess
now I see it, one LED with.
Yeah, okay, sorry about that. So now do you see anything or no?
Yes, we see one slide with one LED light against a pink fabric.
Okay. And let me see. Now do you see stuff?
We see the same
Do you see a different picture? No. Okay, so I'll do it this way. It's funny, I guess you can't play a slideshow and Zoom. This is good to know, to figure this out. See, you would have thought I would learn this already, but guess not. Okay, let me just make this a little nicer to look at. And sorry, guys. Okay, anyway. Okay, so, so I played around with like different ways to combine fabric and electronics. And I showed you just this really simple circuit is one example of that. It seemed like such a cool, interesting kind of new set of materials, a new way to work with electronics that I was really curious and excited to like share that experience with other people. So then I started teaching a bunch of workshops to different kids using kind of textiles and electronics as a way to introduce them to computer science and also to electronics. So you would kind of get these materials and then through kind of building these interactive constructions, kind of learn these things. This is just a snapshot from one of the early workshops that I taught called Interactive Fashion. These experiences led me to actually make a commercial version of the kit. So early on, my experiences were all the pieces that I made were like hand built and hand constructed. But I then transitioned to this commercial version of the kit. This is an early version of what's called the Pad Arduino Kit. And here it's just traditional circuit boards, but that are made in such a way that they can be sewn together with conductive thread. So maybe you guys saw a little bit of these. And that was fun because it allowed me to like make more complex projects and then also to share this whole field and this whole space with lots of other people. So here's this was a fun early project that I made too that I actually used a lot. This is a jacket that I made with turn signals sewn onto the back and had little switches in the cuffs so people could like see where I was going when I was riding my bike around town. And then here are a couple of projects that kids did in workshops that we taught. Again, you can see they're fabric and electronic. The one here on the left is a little fabric piano. So each different color that you touch there corresponds to a different note. So it's like a piano type of musical instrument, but electronic. And then on the right is this stuffed animal that when you squeeze its ears, the harder you squeeze, it'll make like different sounds and play different music for you. And also its eyes will flash in different patterns. You can see its ears are just made out of tinfoil that's ironed onto a piece of fabric. So it was really fun to see like what other people were doing with the lily pad and to see that lots of people were picking it up and using it to do all sorts of wonderful things. I won't play this for you. I'll maybe play some other videos, but there are lots of fun examples online that I've collected in some of my research projects, just documenting, like, especially on YouTube and stuff, like fun projects that other people have done with the lily pad. It's been really interesting. And among other things, we've been able to document that the group of people who build stuff with the lily pad Arduino is just really different from like traditional like computer and like electronic folks. In particular, many more of them are women and girls, which you might expect, because that's a traditional thing for girls and women to do, right, is to work with fabric and fashion and electronics. But that was like a pretty neat outcome. Anyway, so that's some of that work. It's been also wonderful to see that it's been used in all sorts of different contexts. So this is a project, for example, where it's been adopted by a national computer science education project and is used in like the Los Angeles public schools to teach electronics and computing and stuff also. So that's been fun. So I want to shift to a different project now and share some of the work that I've done that's similar in a lot of ways, but around paper and paint and electronics and computing. So similar to the way conductive thread lets you make like electronic stuff and like little computers in Fabric, there are these really cool materials, in particular conductive paint and conductive ink, that lets you make electronics on paper, or essentially make electronics on any sort of surface that you can paint, which was also really fun. So this is a snapshot of just a really simple electronic circuit painted onto a page of my sketchbook. So the black thing that has these legs coming out, that's a little miniature computer. You can see there's a big battery and then a couple of lights, and they're connected by this painting or drawing in conductive ink. So again, I played around with just different things that you could do with conductive ink and electronics. And then we started, then I started to work on larger projects. So the next few projects that I'll show are done in collaboration with a team of my former students at MIT. One of the things that we did is we started to work on a series of wallpapers. So we would paint really large sheets of paper, or actually just really large walls, with a conductive paint and regular paint to make these very large kind of interactive surfaces. So you could touch different parts of the wall to turn lights on and off. The wall could measure your temperature, the temperature of your environment, or its light levels or pollution levels, kind of things like that. We also did things like you could touch different parts of the wall to like control your music playlist. So things like that. This is a close-up of one of the wallpapers that we made. Here's a larger shot of one of them, so you can see kind of, they were quite large. And here the idea is just like rethinking, like when you can paint with electronics, like you can think about electronics and computation in a very, very different way than you would if you're just making like tiny little circuit boards, right? Like all of a sudden, you can approach it in just a very, very different way. And one of the things that I continue to be interested in and excited about is that you can make like technology that's really beautiful and kind of embedded in your day-to-day life in a new and interesting way. Or, maybe I'll play a little bit of this video and tell me if it's awkward, but you can see some of it. Video quality isn't so great, but. In this version also, we played around with magnetic paint also, so all of the electronic pieces are magnetic, and so you could move them around to create like different patterns of lights and movement and stuff across the wall. Let's see. Show one more little thing and then we'll skip ahead.
Are we supposed to be hearing something?
Not yet.
Oh, okay. I love the spinning.
So here's just a little, so here was this, just this little one where we had it controlling like the music in our lab space. Anyway, so I'll skip ahead now. So that gives you a sense of some of those projects. I also began to collaborate with this amazingly wonderful student of mine around this time named Ji Chi, who was essentially just a master at paper crafting, and in particular a master at designing and building pop-up books and origami, and actually all sorts of things. But one of the projects that she worked on that was so lovely and wonderful was an interactive pop-up book with electronics kind of embedded into this beautiful pop-up book that she designed and created. So here's one page out of that pop-up book. I'll play you a little bit of a video of that, of the rest of that book. I'll go ahead and stop that now, but that gives you a sense of some of what that pop-up book looked like. Like skip some of these. You can find G, who built that pop-up book with a little bit of help from myself and a couple of other people, but has done all sorts of wonderful art projects. If you search for her online, you can find beautiful videos of other kind of electronic kind of interactive paperwork that she's done. This is another piece. I won't show you the video, but it's also really gorgeous. In similar spirit to the work that I did in electronic textiles, we also were interested in like helping other people like do this kind of stuff and make these kinds of projects. So we also did a bunch of workshops with different people, kind of using paper and paint and electronics as a way to, again, like have them learn about electronics and computing, and also just make like cool, interesting, neat projects. So these are pictures from a workshop that we taught where students could made these drawings, and then they could like attach them to their computer with a little clip, and then create kind of interactive stories on their computer that would be triggered when they touched like different parts of their drawings. Here's a simple workshops where kids are making just circuits out of copper tape and electronics. And this is now an activity. It's been so fun to see this. This is now an activity that's pretty popular, and maybe you guys have done this too. This kind of using copper tape and electronics and paper in this way is essentially something that my student G like invented, and now it's like done all over the place. So it's been so fun and exciting and cool to just see that process, that this work has really gotten out into the world in all sorts of fun ways. I'll play you a little bit of this one last video about some of our work in paper-based electronics, which is eventually kind of G developed a company that came out of this work that we did. And there's, she did this company called Circuit Stickers so that you could have an easy to use kit similar to LilyPad that you could use to make kind of paper-based electronics. I'll play this a bit for you. that was another project that came out of that work. Let me quickly, so this has been one big aspect of my work, kind of embedding electronics into different kind of weird materials and playing with them, and then developing both design work with those combinations, but also helping to make things accessible and using them as a way to teach people about technology. I've also more recently been really excited about a different way to kind of connect computer science to the physical world and to kind of design and art and stuff. And that's through this process called computational design and fabrication. So the idea is you write a program which then generates like the design for something. So maybe that's a cup, or maybe that's a dress, or maybe that's a building. And then you can use a combination of like hand building and also new machines like 3D printers and laser cutters to kind of build that thing out in the physical world. So just a couple of professional examples of how this works. These are two artifacts that were designed by someone who wrote a program that generated the design, and then they were built in the real world in different ways. So the image on the left, this is a new skyscraper that went up recently in Chicago, designed by the architect Gene Gang. And it's just this crazy, beautiful structure that really couldn't have been designed at all without the use of computing and computer science. And then this was built using a combination of like fabrication and traditional like building construction methods. On the right, this is a fashion designer that's maybe my very favorite fashion designer right now, a woman named Iris Van Herpen. This dress was also designed by kind of writing a computer code that generated these gorgeous kind of undulating patterns. And then those were cut out on the laser cutter to make these kind of lacy shapes that were then stitched together by hand using traditional like couture fashion techniques. So the point here is that computer science can be used in design in all sorts of beautiful, interesting ways. And that I'm very interested in exploring those spaces, but also finding ways to make some of these approaches like accessible and available to different people. Because right now it's just kind of like high-end designers who play in this way, and it can and should be lots more people who get to do this fun stuff. So again, with some of my former students from MIT, we worked on a series of projects exploring some of these spaces. So this is one example project. This was a project where you could write a computer program to generate a pattern, like a beautiful pattern to make a lampshade. And then software that also kind of went along with your computer program would help you design the form of the lamp. And then it knew how you were going to build the lamp. It knew something that you were going to build it out of wood and paper, and it would help you kind of with the design of like the construction that you would have to put together. So you see the different views of the software here. You see the pieces of the lamp that were cut out on the laser cutter in the upper right-hand corner, and then you see a finished lamp down here at the bottom. So what was neat about this is that you could use this system to make lamps that the software really helped you build, but you had a lot of creative control over what the lamps look like. So you could control the shape of the lamp and also, again, write programs to control the decoration that was on the shade. And so you could make all sorts of different, like really beautiful constructions. So these are some of lamps that other people designed in workshops that we taught. So one example of how beginners can write programs that generate like beautiful things that you can then go and like use in your house. One of the reasons that I think this is cool is that you really can like use these things in your house. You can write a program to make something that then you use in your house or just in your day-to-day life. that, you know, reflects like who you are and what you're interested in and what you think is beautiful or cool. So these are a few things that I've, over the last few years, have designed through writing code and then made in different ways. So I've been doing a lot of ceramics. You can make jewelry. These are etched out of metal. This is a handbag that I made where the pattern is like a math equation, essentially, that's then cut on a laser cutter. And then another one is cut on a laser cutter also, and then ironed onto a t-shirt. And then I use these in my day-to-day life in all sorts of ways. So here's my son drinking out of a cup that I made. This is a rug that's in our house. This is a curtain that's in our house. Again, kind of designed with a computer, and in this case, again, laser cut. And then we've done, again, a lot of work kind of helping different people like write code to make these kinds of things. So this was a computational fashion design workshop that we taught to a group of young people in Boston. Here, these are scarves that they made with computationally generated patterns. And is there? No, there's not a, anyway. They also got to design like a dress that was shown in a fashion show for Boston Fashion Week, and that was really fun too. One last thing that I just wanted to mention that before I stop, that I'm especially excited about in this space, being in New Mexico and kind of coming back to where I grew up and stuff, is thinking about like, there's so many amazing like art traditions in New Mexico that are also, even though we don't think of them this way, like very connected to mathematics and potentially to like technology and computers. So this is a beautiful Navajo rug, like a woven rug. And for those of you who don't know, actually the history of computer science and the history of like computers is really connected to the history of weaving and the history of looms. Essentially, the loom was like the first computer, and the loom was what inspired people to build more complex computers. They're like the ancestors of the computers we use today. And so looms and weaving and computer science have all of these deep connections. And so there are lots of natural connections that could be made, for example, between like traditional kind of art weaving here in New Mexico and technology. This is another example that I'm really interested in. So this is handmade, like gorgeous Acoma Pueblo ceramics. One of the things that is so beautiful about them and striking to me is that these are really complex, like mathematical objects. There's this amazing kind of symmetry and like repetition of patterns in these artifacts. And these are something that we could learn a lot from as like technologists and as people who, if you're interested in like computing and design, these are artifacts that could potentially have a lot, there's a lot that we could learn from, like how people make and build these gorgeous, like mathematically kind of rich objects. So all sorts of potential to learn from like New Mexico culture and heritage here, and to have that inform like technology design. And then just one more fun example, because I think it's so cool, more on the tech side. One of the things that people have been working on, not me, but others, is Adobe 3D printers. So 3D printers that can actually, like a robot that squirts out essentially an Adobe paste to like build a building. So like a giant robot that will squirt out this Adobe paste to like build a building. Like, and so this is one just example prototype that I love, because it shows you like the wheelbarrow and the hoe and everything. But there, again, like lots of potential connections between stuff that we, you know, grew up with in New Mexico and know how to do, and like really cutting edge technology. So those are some of the things that I'm really excited about exploring, like in the future, and kind of being here in New Mexico. So, okay, I've talked long enough. So thanks a lot. And I'd love to hear your thoughts and hear, yeah, answer any questions you might have.
So there are a lot of questions in the chat.
Oh,
You want me to read them to you?
Well, I can stop my screen sharing too.
Okay.
That might be, then I can read some of them too. But
so there was the first comment around Marcus Martinez, I think is when they started, and he's talking about the wallpaper technology reminds him of Meow Wolf.
Yeah. Totally. There's, yeah, Meow Wolf is great. And there's definitely connections there. Yeah, totally. Yeah.
And then I was chattering. And then the next question is, where can you get conductive paint markers, etc.?
Yeah, that's a great question. There are, so Amazon isn't a bad place. You can find some conductive pens and markers there. There's not like a wonderful marker, or there is like a really great marker that's really expensive. Unfortunately, there's not anything that's really great that's cheap. The copper tape is really, really cheap and more accessible, which is why a lot of the educational stuff we did started to head more in the direction of the copper tape. But so Amazon is a decent place. You can find a variety. Like here, for example, is one. This is like a copper-based or a nickel-based paint that you can paint with. That's kind of neat that I just got this from Amazon. But also there's a weird company called Less EMF. And they have all sorts of neat materials. So,
their customers are musicians who want to shield their guitars and stuff from extraneous electromagnetic waves, and then other people who, you know, want to shield their heads and their houses and everything from extraneous electromagnetic waves. And then I think the next question was, what programs do you use to program the electronics?
Yeah, different ones. A lot of the electronics are Arduino based. So just like the Arduino that if you guys have been learning that's the same thing that we have used. There are other programs that we sometimes use to just program like the chips by themselves and stuff, but it's very similar to Arduino. So more or less like Arduino kind of.
And then around 212, if you want to, is Mac had a question. How much do the Arduino lily pads cost?
Yeah, so a lily pad, you can get just the standalone lily pad for like about $20. And like a starter kit for more like 30 or 40.
And SparkFun is one place that sells them and does a lot of support on their website for it. Do you see the next one at 212?
Yeah, I don't see the, oh, okay. Yeah, so our conductive surfaces used on a large scale now. Not in the way, so like not along the lines of some of the stuff that we did. So we haven't, like I haven't seen any other people do anything quite like the wallpaper or something. I should say I'm right now working on a project here at UNM to use similar technology to make interactive murals. I'm working with the wonderful mural artist here in Albuquerque, Nani Chacon, and we're working on, we just started collaborating, so it'll be a year or two before we have an actual mural, but we're working on using that technology in that context, which I think will be really fun, even much bigger than the wallpaper. I think it's possible that they'll be used in the future. In terms of like I think there are lots of really cool possibilities for like artists and, you know, I don't know, graffiti artists and stuff to pick it up. Among other things, there's like conductive spray paint and stuff that you can do really fun stuff with. So
Oh, there is. Okay. And then the next question comes at 2:13.
Let's see, how long did it take you to alter the black jacket? Oh, the like biking jacket. Yeah, so I just got a jacket. I think it was like just a jacket from like the Gap or something. And then I just sewed the electronics into it. How long did it take? You know, a couple of days, something like that. You know, hand sewing is labor intensive. If you use the sewing machine, you can go more quickly. But if you're sewing by hand, you know, takes some time to sew stuff by hand. But not like a crazy amount of time, just a few, you know, a weekend or something. I have not made face masks, although I think there are interesting things you could do there, like, you know, embedding sensors of some sort and, you know, potentially little like vents or something that could open and close in face masks with embedded like electronics. So I think there could be really neat things to explore there. I think that's a wonderful idea, but maybe, I don't know, maybe one of you guys could build something like that for a project.
I gave them a pattern for a face mask. It has a LED array.
Oh, cool.
And it says 6 feet and stay away and germs and all that.
Cool.
I think that was the last question. I also, I just noticed somebody in the School of Architecture who incorporates photovoltaics in with her concrete design. Are you familiar with her at all? I forgot her name.
I don't know that I know her.
Yeah.
That sounds neat. Yeah. No, there are also like flexible solar panels and stuff.
Oh,
that you
yeah.
can go into things, which is really neat, and actually little flexible batteries and all sorts of neat stuff.
Yeah, and this group again is doing the land art project, so they're designing art and renewable energy art installations.
That's awesome.
So any of you guys have any other questions? What classes do you teach?
This fall, I'm teaching like the introduction to computer science class at UNM. So the introduction for like computer science majors. So it's CS 152. That's
not a dual enrollment class, is it?
I don't think so. It's not cross-listed or anything. But you don't have to be a major to take it. It's open. Yeah. And I think you can get some sort of UNM credit for taking it. I think I should be careful about that, but I think it can fulfill either, I don't know, perhaps a science requirement, but I'm not totally sure, so I should be cautious.
Could you also tell us about your background? Because I know it wasn't straight computer science, right?
Yeah, sure. No, it wasn't. So I started out, as is probably like obvious from some of the projects that I've worked on, like I've always been interested in like art and design and stuff, as well as kind of like math and science type stuff. So when I first went to college, or even like in high school and even before that, like I always was, interested in math on the one hand and then kind of art and design on the other. So when I first went to college, I was like a dance major actually. And then I felt like, oh, well, I probably can't really get a job with a dance degree and, kind of that typical thing. And I thought I could still do all the dance stuff that I wanted to do in college and get a more academic degree. And so I ended up majoring in physics, somewhat randomly. Then I lived in New York City for a while and did like dance and art and stuff, and was just like a starving artist in New York. And that was really fun, but I was really poor and I had to work like dumb jobs to like support myself. And at that point, I decided to go to grad school, and also a little bit randomly decided to go for computer science. I thought about physics, and I thought, I don't really want to be a physicist, I don't think. But computer science seemed really cool to me. It seemed like a really creative discipline. Like you build stuff when you write a computer program, like you're making something kind of out of code, out of like math stuff kind of. And that was really appealing. It just seemed like fundamentally creative. And so I still really think that's true about computer science. I love that about it. It's really creative discipline. Like you build things when you work with technology. So anyway, that's how I wound up going to grad school for computer science. And then I was just really lucky to find people in grad school where I learned that you could combine kind of art and science and technology and education, and that was something that people did, and I could have a career doing that. And that was really fun. And I was lucky to find those people and have them help me and work with me. So.
Some of the students in this camp would like to go out of state for college. Was that important for you?
Yeah, no, I mean, so I grew up in a really tiny town, like up in the mountains in New Mexico. And so I was like, I really wanted to go somewhere super different for college. You know, most of the kids in my high school didn't do that. So it was kind of unusual, but I really wanted to. And and I really wanted to go to New York City. I had it in my head that was like where I wanted to be. And I didn't really, so I just applied to a bunch of colleges like in New York State. I didn't really understand the difference between New York State and New York City. So I wound up going to college in a little town in New York State that was like about a 4-hour drive from New York City. But it was still really different from New Mexico, and it was fun and it was great. Super cold and dark in the winter, which sucked though. But I missed New Mexico. I'm glad to be back.
Do you have any advice for the students about COVID and college and what to do about that?
Yeah, I don't know what to say. I'm sorry. It sucks. I'm sorry, like for you guys, it sucks. What a crappy time for this to be happening. I mean, it's also like really crazy and interesting. So you're having this wild, really unique experience. But I don't know what to say. I feel like it sucks for all of us, and for you guys probably more than as much as anybody, like having this time in your life being kind of just put on pause. I'm sorry. I feel like, sucks to teach this way. It's not nearly as good as it is in person. Sucks for us all to be just home alone all the time by ourselves. Sucks to be scared and stressed out all the time. Anyway, I'm sorry. It's crappy.
Can we take that and play that?
It's not advice. Sorry. I don't know what to...
No, I think it's great. So do you guys have anything else you want to say or questions to ask? I just like to echo one thing that you said. That my son, who was a computer science major, and one of the things he really likes about computer science is that you can see results really quickly. It's not like research that you have to wait, 5 years to see what you're doing, and that you can build something like that almost out of nothing. And same sort of thing that you said, that just and then it's there, and you make something pretty fast. So I think that's kind of cool. With me, I just make so many, typing mistakes that it takes so long to find the bugs that that took a lot of time. But for him, he really likes being able to do that.
Yeah.
Okay. Well, thank you again for doing this a second time. We really appreciate it, and I enjoy your presentation every time. I think these guys know how much I love intersection of art and everything science. So I've dragged them along to everything like that, but I think they enjoy it too. So I really appreciate your talking to us.
Well, thank you all so much for listening to me and asking.
You got a ton of thanks here from everybody in the chat.
Thank you guys. Okay, well, have a good rest of your day.
Thank you. You too, Leah. Bye-bye. And for the rest of you guys, your land art going okay? Is there anything you want to ask me or tell me about anything? No? Okay, then enjoy the rest of your afternoon. And we'll see you tomorrow at 1:45 with your presentations. And I can't wait to see what you do. And just relax, don't worry about it. This isn't school. Have fun and make sure everyone has a voice. So I'll see you guys tomorrow.